So here we go. Let's look at these last few questions here. There's a little bit to do. So one's direct proportion, proportional to the cube, proportional to the square, proportional to the square root. Okay, so let's just link up anything that's obvious to begin with. Well, I should be able to find this one here. Right? I should be able to find one that's direct proportional to x, because all I'm looking for is, can I find a number that multiplies by this and multiplies by this, right? Can I find, right, that's clear, that's times 10, that's times, yuck, times a half, wait a minute, so A goes with L, so that one and that one, and then which graph? Direct proportion, straight line, okay, so A, L, T. Now let's have a look, let's see if we can work out B, which one's going to be the square of x. Well, I know one thing is, I can do that there because that's the one that we're looking at, but I know that it's going to be that graph, okay? It's a quadratic, isn't it? So I've got B that goes with S. Now what I don't know is I don't know which one of these guys is going to be the one. So let's have a look, see if we can work it out. So I'm going to take a guess, right? Let's have a look at this one over here, right? I really don't know what the answer is, but we'll have a guess and see if we can work this one out. So I square this number here, so remember what we're looking for is, can I find that? Can I find that that works with this? Remember, the easiest thing to do is just to cover up the 270, just pretend we don't know that, and then work it out and see if we end up with 270. So if that's 1, so that would give me k1 equals 10, so k would be 10, right, to make that work. So y equals 10x squared. Right, so let's see if this works. So 3 squared is 9 times 10 is 90. Ah, that's annoying. So it's not that one. All right. So let's go and try this one maybe. Okay. So we'll have a look at this one. So let's try it and see if we can work this one out. Just move that along a little bit for you. So let's see. Remember, we want to try and get this. So if I square the 2, that's 4. So 4 times 5 is 20. Alright, so in other words, it's that. Right, so now let's work out this one. So 5 squared is 25, multiplied by 5. Yay, it's that one, it's M. Alright, that's the square one. Okay, let's take a guess on this one. So let's go with the cube one. Again, I should know which one of these it's going to be. That's a cube, that's a cubic, just there. So which one have we got? We've got C. So C goes with graph R, and I need to work out which one of these. I just got a hunch it's going to be this one here, so let's come back to this. So remember, what I'm looking for is I'm looking to see if that will fit. Sorry, that is a cube there. So K would be 10, so again, so 10 that's cubed. Let's see if it works on this one. So 3 cubed is 27 times, yay, it's that one. Oh great. And then, so we've done that one. So what we're left with, D, and which one have we not? Oh, not done this one over here. Right, actually that kind of makes sense, doesn't it? Because you're looking at the 4s there. All right, it was kind of sort of the slightly odd looking one. And which graph have we not done? Not done this one over here. Okay, and you could have a little think about why that graph fits over there as well. Okay, right, there you go. There's number 5, the answers to that one there. Right, and number 6. Here we go. Right, so we're gonna have to draw a table for each of these things here. Fortunately, I've already got the tables drawn. Right, there you go. Bit of planning. Right, so the first one, y is inversely proportional to x. So let's write down, what do we know? So we know y is inversely proportional to x, so therefore y is inversely proportional to x. Let's get that right. And so we know that. Where's the link? There's the link, just there. So 6 equals k over 2, so k must equal 12, right? I'm doing this a little bit too quick. 12 over x. So 12 divided by 4 is 3. 12 divided by 6 is and these guys over here, they're all just going to be negative version, aren't they? Okay, minus 6, minus 3, and minus 2 for the last one. What's the graph going to look like? It's going to look something like this. And again, just get used to seeing this. You get this kind of weird effect kind of coming up like this. And it ends up being the same, but it's going to be in negatives with these ones down here. Okay? And remember, these are asymptotes, these points. Asymptote, you never quite get there. There won't be an answer for 0 if I try x equals 0, because 12 divided by 0, it's not going to happen. And also, we're not going to get an overall answer of 0. When's that going to happen? Okay, so let's have a look at part 2. So part 2 is y is inversely proportional to the square. So let's have a quick look. So y is inversely proportional to the square of x. Right, let's go for it. So y equals k over x squared. So if that were 4, so 2 squared is 4, multiplied together, 24. So y equals 24 over x squared. Right. Right, we might use this guy down here. Alright, so let's have a little look. So 24 divided by 16. Right, 24 divides 16 equals 1.5. 3 over 2, maybe. 24 over 36. That's going to be 2/3. I'm going to bother doing that one. And then what we're going to get here? We're going to get exactly the same answers, because when you square this, you're going to get a positive. So it's all going to be exactly the same. What's the graph going to look like when we do this? Well, it's kind of quite similar to this one. It's going to be a bit like that, in there. And then this side, it's the same. It's symmetrical about the y-axis, right? Which is kind of quite neat. Right, let's move down. So part 3 was y is inversely proportional to the cube of x. So what does that mean? Right, I'm going to jump a little stage there. Oops, k over x cubed. Okay, so if I substitute in when I've got 2 cubed, that's 8. And that's equal to 6. So 6 equals k over 8. So if I multiply these two together, I can find out what k is. So what's that? 48. So y equals 48 over x cubed, just there. Right, so 48 divided by, right, okay then, so let's just quickly do this. So what have we got? We've got 48 divided by 4 cubed. It's going to give me 3/4. And then 48 divided by 6 cubed. 48 divided by 6 cubed. 2/9. And then these ones are going to be the same, but negative. Minus 6 minus 3 over 4 minus 2 over 9. And the graph of this is, it's actually quite, it's sort of like a sketch. Just doing that would be absolutely fine. Okay, it's going to have the same features as that up there. So it's going to be a bit like that, right? And then, right, we're nearly there. And then inversely proportional to the square root of x. So, whoops, I'll peep at that last question. So y would be equal to k over the square root. Right, got a feeling this might give us something slightly different. Let's have a little look. Still got to work out this k thing from here. Ugh, not very nice. So what are we going to have there? Right, when we go and put this in. So if I put a 2 in there, got a 6 up there. So 6 equals k over root 2. So k equals 6 times root 2. So that's not very nice. So I'm just going to write it like this. So 6 root 2 over the root of x. Alright, that's really not very nice. Right, let's quickly do this one here. So that's going to be, if I plug that into my calculator, I'm going to have root 4, that's 2, so that's going to give me 3 root 2. If you write that as a decimal, I think it's 4.2. 2, what did I just say, 3 root 2, 4.24, that's what I was thinking. Okay, it can be around there somewhere. And then this one is going to be, so you've got 6 root 2, so what am I going to type into my calculator? And we're going to have to type that in, aren't we? Okay, it's going to be, let's just go for it. So 6 root 2, and then we're going to, whoops, let's just do it as a fraction. Okay, be better. 6 root 2 down onto the bottom, root 6. It's much easier to enter like that. Equals 2 root 3, which is, if you want to put that as a normal number, well, say a normal, just to round the decimal off, 3.46. Now, weirdly, there are no answers there because you can't take the square root of these numbers. So when you go and draw your graph, or just drawing a quick sketch, it'll be a bit like that bit, just there. All right, simple as that. It looks like the most complicated one, but that's actually it. Right, let's have a quick look at the last question. Okay, so what I've done for each one is I've just summarised what's there. It looks really complicated, but actually there's not a lot to do on this. In the following situation, state the constant proportionality actually represents. So we'll have a little look. I'll talk you through. Okay, so this is what the first one tells me. Time taken for a journey is inversely proportional to the speed travelled. So I've written that down. Hey, wait a minute. What's speed times time? What's that equal to? The speed multiplied by the time. K here would be the distance travelled. Okay, let's have a look at the other ones. They're quite similar. The amount of VAT paid on an item varies directly as the cost of the item. So we write that. So what's the K represent here? K here represents the percentage rate of VAT, of the VAT. Alright, and let's have a look at the third one here. What have we got? It says the length of a rectangle is indirectly proportional to its width. So we got this. So length equals K over L equals K over W. Multiply these two things together. It's the area. Right, if you imagine length times width is area, isn't it? Alright. D, what have we got here? It says the length of an original photograph, so I put that there, is proportional to length of an enlarged photograph. So in other words, this K is the enlargement. Right, a little bit harder to think about what's going on there. And the last one, let's have a little look at this, see what it says. It says the height of a cylinder is inversely proportional to the area of the base of the cylinder. So I can write this down. Well, what do you get if you multiply the area of the base with the height? You get a volume. There you go. Right, a little bit different those last few questions. Well worth looking at, and if you understand those ones, you're doing really, really well. Okay, I'm not expecting you to be able to have done everything that's there. That's fine.